Hi, good morning. So, today what we're going to do is to discuss the questions that I gave you last time. So, if you remember, that's May June 2019 and that's paper 12. So, it's a multiple choice paper. Let's just go around, go about the answers and the questions very quickly. Also, to know like which way, like what is good, like how do we answer the questions in a way that we don't waste so much time, because remember paper 1 is an hour 15 minutes, so basically you have a minute and a half to answer each of the questions. So let's go directly to question number 1. So question number 1, we want to know the equivalent of 2000 microvolts. So if we can write it down, so that's 2000 micro is times 10 raised to negative 6, but we also know that the three zeros there can be 10 raised to positive 3 there. So combining this and this would give you 2 times 10 raised to negative 3, which is basically 2 millivolts. So in that case, your answer must be B, 2 millivolts. Next, for question number 2. So you're asked to express electric field strength and powers in SI base unit, and we want to know how many SI base unit is required to have both. So you have electric field strength, which is for point charges, F over Q, and then power is just work over time. So in that case, both of them has F, so that's kg ms negative 2. You have kg ms negative 2. You have D here, that's M. All over you have time, that's S. And then on the other side, you have Q, which is equal to IT, which is AS. So you count the SI base units here. So they have 1, 2, 3, and 4. And then on the other side, you have 1, 2, this is the same, 3. So you have 4 here, 3 here, 4, 3. So the answer must be D. Now let's go on to question number 3. So Planck's constant H, SI unit is JS. So you want to know which of the following can calculate Planck's constant. So let's try each one. So here you would have D is for distance, so that's M. E is for energy, that's J. And then velocity is ms negative 1. So following dE over V, dE over V, which would be mj all over ms negative 1. So simplifying that, you cancel m and you would be left with js, and that's already Planck's constant, or the unit for Planck's constant. So you don't have to go through each, but if you have to, you would notice that this is ms and this is m. That's not equivalent to joule. This is joule, but you don't have s there. And then you have kgm. Oh yeah, so definitely not this one. So definitely the answer must be A. Okay. Now question number 4. So question number 4, you want to find the magnitudes of the horizontal and vertical components of the resultant of the two forces. So just do x and y. So x and y. So for the first, this is the first and the second force. So first, second force. First force, x, this is 15, adjacent 20. So you have 15 cosine 20, positive because it's going east. For here, you would have like this. And then this is plus 6 sine, because it's opposite the angle, 40. So you have that for x. For y, on the other hand, you have this. So for 1, that's 15 sine 20. And then you have this as the vertical component, so that's minus 6 cosine 40. So simplify the x and y. For x, you have 18 newtons. For y, this is 0.534 newtons. So find that in the choices. You have C. Let's go to question number 5. So question number 5, you want to find the uncertainty, percentage uncertainty of the calculated value for rho, which is density. So you have rho as m over v, but you're given the mass, so that's for m, and then the diameter instead of the volume. So we also know that to calculate the volume using the diameter of a small sphere, then v must be equal to 4 over thirds by r cube. So in that case, you don't, so in terms of diameter, so you don't need this because those are constants. So you just have r cube in terms of diameter, that's d over 2 cube. So you have d cube. So to find the percent uncertainty, we know that the formula would just be percent uncertainty is equal to delta m all over m for the mass, plus, since this is d cube, you have 3 delta d all over measured value of d, and then multiply it to 100, so to get the percentage uncertainty. So in that case, that would be 0.005 all over 0.506 plus 3, and then you have 0.02 all over 2.20, and then get that, multiply it by 100, and then you get the percent uncertainty as 3.7%, which is choice letter D. Then let's go to question number 6. So question number 6, you want to find the graph that shows that there were random errors. So if you remember, for practical paper 3, we discussed about different types of errors. We have random and systematic. So how do we define that? So here, so the two types, systematic and random error. Systematic error would be a zero error or an inaccurately calibrated instrument, and then a random error would be parallax error, careless in making readings, or wrong techniques. So if the errors are random, then you would have mistakes on the, like, if you look at the graph. Okay, so let's eliminate first. D is okay, so eliminate that. Eliminate also B. So basically A and C. Obviously A is an anomalous result, but since C has have errors in like left and the right side of the graph, so meaning the reading technique was wrong, so definitely C would have random error. Okay, let's move on. Question number 7. So which statement best describes precision and accuracy of the weighing scale? So precision is the closeness of the values that you got from the different readings, and accuracy is like uncertainty, a measure of uncertainty of your device. So we know already with that the percent uncertainty or the absolute uncertainty of the device is plus minus 0.1 kg. So meaning it's not accurate by 2 or plus minus 0.1 kg. So B or D. But if you look at the closeness of the readings, you would know that it is precise to 0.1 kg. So this is plus minus 0.1 kg. So precise to plus minus 0.1 kg. So the answer must be D. Let's go to question number 8. So you have a graph of a physical quantity that varies with time. So it's just either acceleration for A and B or speed for C and D. We can eliminate. So basically you have here where either the acceleration or the speed is 0, so this point, and then you have like a here vertical line, so that tells you like a switch for either acceleration or the speed. So to do that, let's try to figure out what happened. Acceleration, firework maximum height, falling to the ground. This is just free fall. So definitely not A. If it's speed, not gonna look like this also. So D, speed of the high, leaving the ground, jumping over a bar, descending to the ground, definitely not. So B seems to be the best answer, but let's see if it would satisfy the graph. So acceleration of the skydiver, leaving an aircraft, falling, or opening a parachute and falling to the ground. So when it is falling, we know that acceleration versus air resistance, so acceleration decreases, and then until it reaches its terminal velocity when acceleration is 0 at this point, it opens a parachute. Then so this one is the parachute opening and then falling to the ground. So definitely B satisfies the drawing of the graph. So B is the best answer. Okay, let's go to question number 9. What describes the mass of an object? So this is definition. We know that mass of the object is closely related to its inertia. And by inertia, we know that inertia is the tendency to resist a change in its state of motion. So C. Okay, let's go to last question. So for this part, we're just doing 10 questions. So the last question is about Newton's laws. So here we say a force is needed to give an acceleration to the car A. So you have if you have a car with mass m, F is needed to give it an acceleration of A. Of course you have resistive force because that's what we're looking into, so R. So you can say that to get F, that would just be R, oh sorry, MA. Okay, so wait. Okay, so our first equation would be you have F net is just R plus MA. Okay, now let's go to the second one. So the second one is M, and then you have 2F, and then it would just give you an acceleration of 3A with, of course, still the same R. So in this case, you have the equation would now be, since it's accelerating with 3A, you have 2F minus R is equal to 3MA. So if that's the case, then you can just like have R. Okay, so do we want to find F? Okay, so we can like substitute this to this. So you have 2R plus MA minus R is equal to 3MA. So okay, so you have 2R plus 2MA minus R is equal to 3MA. So you have 2R here and then minus R, so you have R, and then let's just transpose this to the other side of the equation. You have 3MA minus 2MA, so this must be equal, R is equal to MA. So the answer is A, MA. Okay, so that's the first part of our discussion, and on the next part we would be continuing this paper. So I hope these are the answers that you gave me in your homework, but definitely we will go about the next part on the next video. Okay, so bye for now.